Welcome. This is the first part of a three-part lesson on the cast rule. So today we'll be starting off with special triangles using exact values. And so definitely non-calculator. So far, we've done two triangles. And the first one is a 30, 60, and 90-degree triangle. And we set up the ratio of the sides as 1 is to root 3 is 2. Okay, and then other triangle that we did was a 45, 45, 90 triangle, and the sides are in the ratio 1, 1, and root 2. Okay, so that was what we did in the last lesson. So today we are going to see what happens to sine, cos, and tan, that's the primary trigonometric ratios, when the terminal arm falls on, say, in the first quadrant, the second quadrant, third, or fourth. Okay, so let's just start with the terminal arm in the very first quadrant. Okay, last class we looked at the definition of the word terminal arm and the initial arm and an angle in standard position. So this is the angle that we're looking at, right? The angle, the principal angle measured in the counterclockwise direction, that's a positive angle. So what happens to sine, cos, and tan, or the sine, as SIG and sine, the positive sign, negative sign, of the primary trigonometric ratios, right? So let's start with dropping a perpendicular, like we usually do, to the x-axis, okay? And this is going to give me the y-coordinate, this is going to give me the x-coordinate. We know that in this, in the first quadrant, x is positive, right? And y is also positive, right? And therefore, I'm going to emphasize this with a positive x and a positive y. And if this is theta, sine theta is going to be opposite over hypotenuse, and the hypotenuse, we're going to call it r. And r is always going to be positive, right? Because r is root of x squared plus y squared, right? Irrespective of whether x or y is negative, r is always going to be positive. So we have sine theta is going to be positive y over r, right? So here we have sine theta is positive y over r is going to be positive anyway. There's no point putting a positive there. And that is a positive. So that sine theta is positive. What about cos theta? Cos theta is adjacent over hypotenuse. So that's y over r, right? Okay, that looks a little cluttered. Let's put it like that. Okay, cos theta is x over r, adjacent over hypotenuse, right? And that is also going to be positive, right? Because x is positive. And tan theta, what's going to happen with tan theta? Tan theta is opposite over adjacent, so y over x, okay? And both are positive, right? This is positive and this is positive. And as a result, this also becomes positive, right? So sine, cos, and tan are all positive, right? All. So that's where the A comes from. A for all. Okay, all positive. So that is part of the CAST. That's what we're trying to investigate. Okay, what is C, what is A, what is ST? A stands for all positive, right? And that's in the first quadrant. Let's try the second quadrant. What happens in the second quadrant? Okay, let's just put some terminal arm over there. And our usual way of dropping a perpendicular to the x-axis. Sorry, not positive x-axis, to the x-axis. And theta, like last class, we saw that theta goes from here to here, right? And we can use the related acute angle, this related acute angle, to find sine, cos, and tan of that. What happens to x? X is negative. Okay, I'm using red here to emphasize that. Why is x negative? Because this is a negative x-axis, okay? Then this is, in this direction, it is negative x. So x is going to be negative, and the y value is going to be positive, right? Why is y positive? It's positive because this is the positive y direction, right? So y is going to be positive. And r, as usual, is x squared plus y squared, and that's always going to be positive. So if we look at sine theta, cos theta, and tan theta, sine theta is opposite over hypotenuse, so y over r, right? If I'm looking at plus and minus, so that's going to be positive. All of that's going to be positive. If I look at cos theta is adjacent over hypotenuse, which is negative x over r, right? And negative divided by positive is, guess what? Negative, right? And then we're going to look at tan theta. Tan theta is opposite over adjacent, positive y divided by negative x, right? So that's a positive divided by a negative is going to be negative. So guess what's positive in the second quadrant? Only sine is positive. And therefore, we say S, right? So this is one part of the CAST rule, okay? If you're looking at the acronym, CASD, that's the S. S is sine is positive only in the second quadrant. Or rather, sine is, only sine is positive in the second quadrant. Cos and tan are not positive in the second quadrant. Let's draw another terminal arm, and this time maybe in the third quadrant. And as usual, we'll drop a perpendicular to the axis, to the x-axis, okay? Now, what's happening with the y value? Now, this is negative y, right? Negative y is in this direction. So the y value here is going to be negative along with the x value, right? So if we have a negative x value, right, and a negative y value, what happens to sine, cos, and tan? Let's see. Sine of theta. Now, when you're talking about theta, we're talking about this angle from here to here, right? So all the way going from here to here, right? So that's the theta we're looking at, okay? Just to color code everything. I'm going to put this into blue, okay, because the terminal arm is in blue. Okay, so that is one theta, this is another theta, right? And as usual, if you remember, we did sine, cos, and tan for the related acute angle, okay? So we have to use this reference angle or the related acute angle to find sine, cos, and tan. So sine theta is opposite over hypotenuse, and the hypotenuse is always going to be positive. Opposite is negative y, right? So we're going to have y over r, except y now is negative, okay? So negative divided by positive, what's going to happen to negative divided by positive? That's going to be negative, right? What about cos theta? Cos theta is adjacent over hypotenuse. So instead of x over r, we're going to say, well, x is also negative, right? So I'm going to write negative x over r. So negative divided by positive, it's also going to be negative. And tan theta is opposite divided by adjacent. So y over r, both of them are negative, right? This is negative and this is negative. Negative divided by negative is going to end up becoming positive, right? So that's going to become positive. So only tan is positive in the third quadrant. So that's one part of the acronym, okay? So this is where the CAST rule comes from. C-A-S-T is an acronym, right? And that's where the T comes from. Let's see what happens in the fourth quadrant. Take a guess. Yeah, it's going to be cosine, right? That's positive. But anyway, let's check, right? So let's check it anyway. Let's say put a terminal arm here, drop a perpendicular, right? The actual angle goes all the way from here to here. That's the actual angle. But to figure that angle out, we're going to use the reference angle. And we have to use the x and the y with signs. Now, x is in the positive direction because this is positive x, right? So x is positive. What about the y value? Sorry, that's the that's the y value, my bad. Okay, so the y value is negative, okay? Y value, because we're looking at this length, right? This is the y value, okay? So the y value is negative, okay? What about the x value? X value is positive, right? This is the x value here, right? Going in this direction. So if we want to look at sine, cos, and tan, sine of theta is opposite over hypotenuse. The hypotenuse is still going to be r. Okay, the hypotenuse is r. Okay, so sine theta is y over r, except now y is negative. So that becomes negative, right? And cos theta is adjacent over hypotenuse, x over r, x is positive. So that's going to become positive divided by positive is positive. Tan theta, tan theta is opposite or adjacent. That is negative y over positive x, and that's going to be negative, okay? Right, so only cos is positive, and so that is C. Okay, we're going to use this to problem solve. It kind of looks strange, probably right now. I'm thinking, well, what's the point of all this? Well, we're going to use this to problem solve, okay? So these four, in the four quadrants, only one of the ratios is positive in the second, third, or fourth quadrant. In the first quadrant, all of them are positive. So that's where the word cast rule comes from, okay? All right, so essentially, quick summary. All positive, okay? That means sine is positive, cos of theta is positive, and tan is positive. Okay, that's the A. S stands for only sine is positive. Okay, that means sine is positive, cos is negative, and tan is negative, right? And so that this is C, A, S, T. Okay, here only tan is positive, sine and cos negative. Okay. Okay. And here cos is positive. Okay. Sine and tan are negative. Okay, so that's where the cast rule comes from. Okay, the only thing you have to kind of keep in mind is sorry, the only thing you have to keep in mind is this is the first quadrant, this is the second quadrant, this is the third quadrant, okay, and this is the fourth quadrant, but we read this word C-A-S-T. If you don't like that, okay, we're starting from the fourth quadrant and reading it, you can start from the first quadrant and say all students take chocolate or all students take coffee, okay? You can also use that, but it's just not easy to pronounce, okay? A-S-T-C, it's not as easy to pronounce as C-A-S-T, okay? As long as you remember the cast rule, starts from the fourth quadrant, or you start A-S-C-T and you can remember all students take chocolate or something like that. All right, let's do some problem solving. Given that cos theta is negative 1/2, find all values of theta in the domain between 0 and 360 degrees. Right, how do we approach this problem? The first thing we need to do is we have to recognize the sign. Cos theta is negative where? Cos theta is negative in which quadrants? Okay, now if you look at the cast rule, cos is positive here. Sine, cos, and tan are positive here. Cos is negative here because sine is positive and tan is positive, okay? So cos is negative in these two quadrants, okay? So cos is negative, cos is negative in the second and third quadrant. Okay, so first thing you need to recognize is whether the given value of cos theta is positive or negative. We are not looking at theta, we are looking at cos of theta, okay? Where is cos of theta negative? So we have to draw two terminal arms in the second and third quadrant, okay? Okay, and of course, whenever you draw the terminal arm, without fail, you're going to drop a perpendicular along with it, right? So you have a 90 degrees and a 90 degrees. Now, cos theta is adjacent over hypotenuse, right? Cos theta is -1/2. This is always positive because the hypotenuse is always positive, right? Hypotenuse is not going to be negative. Okay, the hypotenuse is always positive, okay? So adjacent value is 2, okay? So that means this hypotenuse is 2 and the adjacent value is -1, right? So that is -1. We really don't need to find the opposite side, but if you're really interested in figuring out, well, what is the opposite side? It's most likely, take a guess. Is it the 45-45-90 triangle or is it the 30-60-90 triangle? You guessed right. It is the 30-60-90 triangle. So we're going to fill this in. √3 and -√3, okay? Because this is in the negative y direction and this is in the positive y direction, okay? But we really don't need that. But if you're really interested to figure out, well, I want to label everything and that's when I can move on, then by all means add that in, okay? But the ultimate thing is we need to find this related acute angle, okay? Because that's the one that's going to help us figure out the actual angle. So what is the related acute angle? It's got to be 60 degrees, okay? So that is the related acute angle. So we have to find the related acute angle, or the reference angle, if you'd like to call it, right? So this is the adjacent side. Sorry. The next step is to find this, okay? So we found that at 60 degrees. So we finally are going to assemble everything. Believe it or not, we're almost done. From here to here is one solution. I'm going to call it theta1. And from here to here is my second solution. It has to hit the terminal arm. I'm going to call that theta2. Okay. The first possible solution is cosine theta is for the first solution for cosine theta is equal to -½ is theta1. Theta1 is a possible solution, right? So theta1 is 180 take away 60 degrees. And what is that? It's 120 degrees. Okay, so that's one possible solution. What's the next possible solution? It is 180 plus 60 degrees, right? And that is 240 degrees, okay? So you're going to write your solution. Your final answer is going to be written like this. Let's get this T out of the way. Okay. Your final answer is going to be written like this. Your final answer is theta is equal to either 120 degrees or 240 degrees. That's it. Okay, so use your calculator and double check. Okay, there's one student in the class who's always checking the internet to see whether Miss A is teaching correctly or not. You know who you are. Okay, so double check that. Get your calculator and actually check what happens with cos of 120 degrees or cos of 240 degrees. Does it actually give me negative 1/2? And it should, okay? All right, let's try another question. Given that sine theta is negative 1 over root 2, find all values in the domain between 0 and 360. Now, what do we mean by the domain between 0 and 360? I haven't really spent time talking about that in the last question. So anywhere from 0 degrees, this is 90 degrees, 180 degrees, 270 degrees, okay, and 360 degrees, right? So that's the full domain. So everywhere in the circle, what are the possible values? So that's what we mean by in the domain of 0 to 360. Okay, so if we go around the circle once. Right, so we need to find, first thing is, where is sine theta negative? Sine theta is negative in which quadrants? Let's go back and look at the Castro. So this is C, this is A. Okay, so only cosine is positive here. So this one, sine is negative, right? Okay, and then sine is positive here, and only tan is positive. So sine is negative in these, sine is negative, okay? Okay, so sine is negative. Okay, so the first step, you have to figure out where is sine negative. Sine is negative in the third and the fourth quadrant. Okay, draw two terminal arms. Okay, our usual story, right? We have to figure out, drop the perpendicular, right? Drop 90 degrees. And then label the sides. Okay, what's given? Sine theta is negative 1 over root 2. Okay, as usual, this is the hypotenuse. Okay, and this is the opposite side. Okay, so the opposite side is negative 1, and rightfully, it should be this one is negative 1 because that's in the negative y direction, right? And this side is also negative 1 because that is the opposite side. And here the hypotenuse is root 2. And we know that because when we drop the perpendicular, this is 90 degrees, okay? We drop a perpendicular to the x-axis. So what about the other side of the triangle? This has got to be negative 1 because it's along the negative x-axis, and this has got to be positive 1. Now let's figure out the angles. Okay, so there are two possible angles, but before we figure that out, we first need to find the related acute angle. Okay, what's the related acute angle? Okay, what is that equal to? That we know is 45 degrees because from the special triangle, that's 45 degrees, right? So 45 degrees. So what are the angles? So the first solution goes all the way from here to here. I'm going to call that theta 1, right? My second solution is going to go all the way from the positive x-axis to this terminal arm, okay? Okay, so that is theta 2. Okay, so what is theta 1 then? Theta 1 is, so I'm trying not to clutter this up, but it does seem to get cluttered very easily. Let's put theta 1 here. Okay, right. What is theta 1? Theta 1 is 180 plus 45. 225 degrees. Okay, and theta 2, what's theta 2? Is 360, right? because all of this is 360, right? So 360 take away 45. Or you could also say, well, 270 plus 45, because this is also 45, right? 360 take away 45. Sorry. Right. So 360 take away 45. Sorry, I just got distracted there for a second. Is 315 degrees. Okay. So your answer is, your final answer, you just combine them and say the solution is theta. Okay, so your final answer, let's get this S out of the way. Theta is 225 or 315 degrees. Okay, there is a bit of analysis here, right? So see if you can follow along, maybe pause the video, talk to each other, right? And let's move on to the third example. And after that, you just have time for doing your homework, okay? So now here with tan theta, it gets a little tricky because there's no hypotenuse, right? That means the denominator can be positive or negative, right? So tan theta, now this becomes a little tricky because there's no hypotenuse. So tan theta can be negative √3 over positive 1, or tan theta can be √3 over negative 1. These two are possible. Okay, they're two possibilities. Whether we have the top or the bottom, it doesn't matter. Tan is still negative, right? Where is tan negative? If you look at the CAST rule, cosine is positive, all sine, cosine, tan are positive. Only sine is positive, only tan is positive. Okay, so tan is negative over here and over here. Okay, as usual, drop a perpendicular. Draw 90 degrees. Okay, so we can have opposite of √3. Okay, negative √3, that would be over here, negative √3, right? So that is negative √3 and positive 1. Or you can have positive √3 and negative 1. So there are two possible solutions. So your first solution would fall over here. Your second solution would fall over here. Okay, so that's your second solution. This is your first solution. But to find that, guess what we need to find? The related acute angle. Okay, so what kind of a triangle is this? It's a 30, 60, 90, right? If you wanted, you could add the other angle. You really don't need it. But if it makes you feel any better, you can say, well, this has got to be 60 and this has got to, sorry, that's got to be 30, right? And clearly my diagram is not to scale. This has got to be 60. Okay, so that's also 60, right? So now you can find your angles. The first angle, theta 1, is 180, take away 60, which is 120 degrees. Okay. And your second angle, okay, is theta 2, which is 360, take away 60, which is 300 degrees. Okay. So your final answer is, you combine that and say, therefore, theta is 120 degrees or 300 degrees. Okay, that's your final answer. So that is the lesson. 3 examples, we're done. For you, your homework are these questions. Okay, so solve for theta in the domain between 0 and 360. Well, if you say, Miss A, can I use a calculator and do theta is equal to sine inverse of 1/2? You can, but it's only going to give you one solution. It's not going to give you multiple solutions. Okay, so be smart about it. We are looking for a whole domain between 0 and 360. So please follow the method I've given you, because if you try to find any shortcuts, you're going to really suffer on a non-calculated test. Okay, so go be methodical, work on your homework, and you can pause the video and watch if you need to. All right. Okay, have a good day. Bye-bye.